Okay, so welcome back to part 2 of this webinar series. I'm going to be talking in this one about how to size a virtual GPU deployment and give you some good tips and some good tools you can use to get a good result and get great user experience for your customers. Okay, so let's take a look at the agenda for this webinar. Well, I'm going to start off by talking about testing density and some of the common mistakes that I found since I've been at NVIDIA that people make while sizing vGPU deployments. What we're then going to do is talk about some starting points, some places that you can start for office worker workloads when designing a system. We'll also talk a little bit about more professional visualization workloads as well and give you some information on that. We'll then go in and talk about some useful tools for sizing, some of the things that I use on a daily basis to get good results. And finally, we'll finish off with talking about how to convince the boss, how to convince upper management that a virtual GPU deployment is right for your business. So let's talk a little bit about density testing and the common mistakes. So the first mistake that I see a lot of people using is using low-end GPU profiles for higher density. So the way that GPU profiles work, we split the GPU in terms of its memory buffer, its frame buffer, between multiple virtual machines. And what people tend to do is they say, well, we want more virtual machines on here, so we'll use the very low-end profile, say for instance 16 1 gigabyte profiles on a 16 gig card, and actually get 16 users on there. Well, that might be good, that might be fine if you're using it for low-end office worker workloads with a couple of HD monitors or something like that. But as soon as you go up to more professional workloads, maybe a 1 gig profile isn't going to be right for you, especially if you're using applications such as AutoCAD or CATIA or something like that. So just be very, very careful to size your vGPU deployments correctly to make sure that you don't get too optimistic and think you can get more virtual machines onto a GPU than maybe is practical in the real world. Another common mistake that I see people doing when looking at the specifications for GPUs is they'll say, well, this GPU's got 2,500 CUDA cores. So does that mean I can split that by 10 users and get 250 cores each? Well, the answer to that is no, because underneath our virtual machines with virtual GPU, we have something called the scheduler, and the scheduler will schedule work across that GPU. At the end of the day, each individual virtual machine gets all of the cores, but for their own time slice. So it's a time slice basis that people get resources here. So be very careful with trying to map GPU cores to users. It's really an equation that doesn't work too well. One of the things that I see people doing often is they'll take a look at the GPU's frame buffer and say, okay, so I've got a 48 gig frame buffer on this GPU, like you can see on the RTX 8000 there. Does that mean I can have 48 users with 1 gig profile, or maybe 24 users on that GPU with 2 gig profiles? Well, the answer to that is probably not. As I mentioned before in the previous slide, every virtual machine gets access to that GPU on a time sliced basis, based on the work done by the scheduler. So, the more virtual machines you have on a single GPU, the more time the other users are going to have to wait for resources on that GPU. So if you think of it in terms of an analogy, it's a little bit like having a jacuzzi, and in that jacuzzi only a single user can get access to that jacuzzi at once. Well, the more users are waiting for that jacuzzi, the longer the queue is going to be. Okay, so just think of it in terms of that when thinking about density. Just because a GPU has a huge frame buffer doesn't mean to say you can get more users on it, because of this contention for resources that is happening within the scheduler. So a lot of load testing tools out there will assume this, okay? They will try to get the maximum theoretical load that they can do onto a server. So there are load testing tools out there and will say you can get 200 users on this server. The trouble is, these load testing tools aren't necessarily taking into consideration what the user wants at the endpoint. So these tools will give you a theoretical maximum, but they're not tracking utilization, frame rates. They're not tracking user experience at the remote end. Okay, so be slightly careful with some of the results you get back out of some of these tools. A lot of the benchmarking tools that are out there that people try to use are really designed to be used in a single GPU environment with a single user sitting at a workstation running those GPU benchmarks. A lot of the ones that are gaming related will champion frame rates as being the most important thing, and the higher the frame rates the better. And people will say, well look, I ran this benchmark on my PC at home and it gave me 140 frames a second. I run it in a virtual environment and suddenly I'm only getting 30 or 40 frames a second. That means that this isn't performing the way I want it to. Well, the reality is, in order to give everyone a fair share of the GPU, what you need to do is artificially limit the number of frames, and we'll talk about that in a second a bit more. Another thing to bear in mind that some of the benchmarks that are designed for VDI scaling, like login VSI, will test that theoretical maximum, but without looking at what the user experience is down at the endpoint. Also, those benchmarks tend to be not particularly graphical in their nature because they're designed around low-end knowledge workers. So if you do have users that are using more video-based content, they're doing things like video conferencing, maybe they're using some low-end graphical applications, then something like login VSI isn't really going to give you the whole story. One of the things I would definitely recommend people take a look at when designing a virtual GPU deployment is look at the future. Look at what applications you're going to be using in 3 and 6 years' time, and then design a solution that meets those particular needs. So more and more people are seeing the need for higher resolution monitors. People are doing, from one monitor, they're now doing 2 monitors. A lot of people are even doing 4 monitors by default. People are using video-based content for training, CEO broadcasts, compliance videos, all that kind of thing. And also they're looking to use things like, Skype, WebEx, all these sort of tools that can create a heavy load in terms of graphics on any virtual desktop. Also, some of the applications that are coming along now have the ability to use artificial intelligence, something that really, a CPU-only solution isn't very well equipped for, but could be baked into a GPU solution. So in the future, if you have applications that rely on some artificial intelligence inferencing, for instance, you could actually utilize that same infrastructure in 3 or 5 years' time to accommodate those applications. Now, one of the most common things that I see when I go out to a customer and they're complaining that performance isn't what they expected from their GPU deployment is quite often they haven't really taken a proper look at some of the remoting protocols that they're using, and they haven't got those optimized. So, VMware has got the BLAST protocol, Citrix has got the HDX protocol, we've got Teradici PC over IP as well. And all of these have various policy settings that can be made in order to make the user performance at the endpoint much better. Some of these technologies, such as BLAST and HDX, have artificial frame rate limits. So the standard frame rate for a Citrix or VMware Horizon session is 30 frames a second. Okay, so if you're looking to get better performance than that, then you better look at changing those policies to try and accommodate for additional frames per second and more desktop smoothness. Another thing to think about with protocols is how are the bitmaps and screens that are being generated actually being sent down to that endpoint. So are you using bitmap and RLE type methods within those protocols, or are you using video-based codecs such as H.264 or H.265? Even within those areas of video codecs, there's some complexity as well. So one of the things that's quite a common thing with the H.264 protocol is the default is to use chroma subsampling, which can make fonts look a little bit fuzzy if you've got a lot of red and blue within that screen. You can change that to use YUV 444 to give you full color access on the endpoint. But this is something you need to think about when configuring your protocols. Now, I went to a customer a couple of months ago, and I know this is a little bit of a tongue-in-cheek diagram here. I'm pretty sure that nobody uses an IBM PC as their endpoint for their virtual desktop. But I went into a customer a few months ago, and they were using a couple of 4K monitors on an endpoint, and they were wondering why, when they moved a window from one screen to the other, there was a lag of maybe a second before the screen would move across from one monitor to the other. Now, what I said to them at the time was, well, have you tried putting in a PC with 2 monitors on it rather than a thin client? And when they tried that, performance changed dramatically, and they actually got a much better performance out of a full PC as their endpoint as they did out of that thin client. I said, well, that thin client, how old is it? And they said, well, it's about 6 years old. And I said, well, that's the thing. 6-year-old thin client might not have the power it needs to take all of this graphical decoding that you're sending to it and actually process it fast enough to get it onto the screen. Okay, so always be careful to make sure that the endpoints you use have enough power to decode all of these bits that you're sending down the wire to them. If possible, take some of the recommendations of the thin client vendors themselves and get some of their higher end models there in order to accommodate your resolutions and screen numbers that you envisage for your users. Okay, so let's summarize a little bit about what we've talked about so far. First thing, make sure that you test real workloads with real users. The best way to assess the user experience, i.e. how smooth that experience is, how interactive the desktop, how responsive it is, and what the color accuracy is like, is to actually sit real users in front of real PCs or real endpoints that have got their real applications on it, rather than rely on artificial benchmarks to be telling you which way to go. Another thing which I'll talk about in a second is to use GPU profiling tools to allow you to take a look at those workloads as you're assessing them doing a POC to make sure that they're not overtaxing the GPU or its frame buffer. And I'll talk a little bit about GPU profiling in a second. Try avoid any benchmarks that were designed for gaming. Things like Unigine, Heaven, Furmark, and some gaming benchmarks that are out there. They're not designed to be used in a virtual GPU environment, and they really assume that you have the whole GPU to yourself. It's not going to replicate what a real user environment will look like with contention on that GPU. Now, if you're absolutely want to use these benchmarks just to test some very basic figures, you can disable the frame rate limiter on a virtual machine to actually get your frame rate up at the endpoint. You can also disable VSync within the NVIDIA driver on the desktop as well, and that will give you that level of performance more or less that you would expect to get from a full GPU. But this is really only to be done as a last resort. And the last thing, be slightly careful with some of the artificial load testing tools that are out there, like Login VSI. They test the response times of that virtual desktop in the data center, not how responsive those desktops are to the end users at the endpoint. They're not particularly designed with hugely graphical workloads either. So as users become more and more graphically aware and applications become more and more graphically hungry, they become occasionally not quite as representative as we'd like them to be. Of course, what you can do is you can use something like Login VSI as a background load generator as well. So what you could do is you could set up a Login VSI run for 64 workstations, for instance, and actually just run 63 and have the last one as a full desktop session yourself. So you can assess the frame rates, you can assess how responsive the desktop is as a real user, rather than relying on some of the output that those tests give you in isolation. Okay, so where should I start? I've got a GPU, I've got a server, I've got a few applications and a few VMs. Where should I start assigning my GPU profiles? So the first thing I'd say is there are two different types of virtual desktop that you might be deploying with virtual GPU. The first is an RDSH based workload. So this is a server serving out multiple terminal services sessions. So for that, we recommend that you would go with Windows Server 2016 or 29. Okay, put 8 virtual CPUs into that virtual machine, a minimum of 16 gig of RAM. On the GPU side, we would definitely recommend something like a Tesla M10. That's a really good GPU to use. It's got a 32 gig frame buffer in it, and you can get a good number of density out of that. Or alternatively, you could use a Tesla T4. Okay, so put 2 Tesla T4s in the machine and it'll give you roughly the same density as a single M10. We recommend giving our XenApp server or our RDSH server quite a lot of frame buffer. So the more sessions you have across that, the more the frame buffer is going to get exhausted. And we reckon that with an 8 gig frame buffer on either at the M10 or T4, you could expect to get about 25 to 30 users maximum on that RDSH server without the frame buffer being exhausted. Again, make sure that you create a full application load on there that's representative of your own application set and where you want to go over the next few years, and use real users rather than simulations to actually assess this correctly. Now, the other type of virtual desktop that most people will deploy is a full fat VDI desktop with each user getting their own Windows 10 workstation to themselves. The recommended starting point here is 4 virtual CPUs in the box, 8 gig of RAM, and again, the Tesla M10 or Tesla T4 are actually really good cards for a standard knowledge worker workload here as well. Now, if you're running a couple of HD monitors, nothing more than HD, and you're running Windows 10, then probably a 1 gig frame buffer is going to be a good starting point if all you're doing is using standard Windows applications, maybe doing a bit of web browsing, a bit of video content, that kind of thing. If you look at putting a box with maybe 3 M10s in it or 6 T4s, for instance, and a lot of our OEMs will offer that choice, you can look to get about 96 users on each individual server. I wouldn't recommend that you try using half gig profiles. I know the M10 has got a half gig profile. I wouldn't recommend you use that with Windows 10. I actually tried this myself a couple of weeks ago, and I tried a half gig profile and I couldn't even get the VM to log in correctly. The frame buffer was not adequate for Windows 10. 1 gig is really the lowest you want to go in there. And again, when you're trying this VDI desktop side of things, try real world applications and real world simulations. Now, if our applications are a little bit more GPU hungry and we're running things like Autodesk, CATIA, Esri, that kind of application, then we probably want to start slightly higher than this. So what I'd say is try, instead of a 1 gigabyte profile, go for something like a 2 gigabyte profile or even a 4 gigabyte profile. And the same would be true if you were using multiple 4K monitors as well. So what tools do I use on a regular basis with customers for sizing virtual GPU deployments? Well, the first tool, and really, the main tool I use to do this, is something called GPU Profiler. This is a free to use tool. It's written by Jeremy Main, one of our top solution architects within NVIDIA. It's not an NVIDIA tool. He actually does all this in his spare time, but it's actually invaluable to sizing GPU deployments. If we take a little look at this video here, you can actually see GPU Profiler working. So you can see here, GPU Profiler is tracking a number of things within this virtual desktop. It's first of all, that green line at the top there you can see is GPU load as we're running this video here. The light blue line is frame buffer. So this is a really important metric to check, to make sure that frame buffer isn't getting anything more than about 80 to 90%. Because when it does get to 80 or 90%, it'll start swapping out to system RAM and you can start getting performance issues. It also looks at standard CPU and standard RAM within that virtual machine. Also, if you look on the right hand side there, you'll see ENC and DEC. So that's the NVIDIA encoder, which is taking the loads off the CPU and encoding all the frames going down to the endpoint in the protocol. Also, if you look at that DEC line, that purple line there, you'll see that that's actually decoding the videos coming in from YouTube. So it's actually decoding that. Now, if you can see here, I've got a little WebGL application running on the right-hand side here, Zygote Body. And as you can see there, it's actually creating a load. And you can see the frame buffer change dramatically when we started using that. Let's launch another application. In this case, we're going to use ArcGIS. You'll actually see the frame buffer is becoming even more loaded as we do that. And what you can do is you can run your standard application set and you can get a really good idea of where your GPU is going to be loaded, whether your protocols are working correctly and whether your frame buffer is getting high. As you can see, that's actually quite high there. I wouldn't be very happy with my frame buffer being up there. I think we're going to start getting performance issues with that in the real world. So there are a load of monitoring tools out there. You might have some of these already. So Citrix Director comes with Zen Desktop, gives you some information and you can track GPU within there. The same with VROps from VMware. you can actually get GPU information in there. There's also some monitoring tools out there. There's a whole load of different vendors out there. One of the ones that we use a lot is Lakeside SysTrack, and that actually is a good way of monitoring GPU performance to get you some really good metrics to help you size your deployments as well. But I'll just give you some of these as reference points, essentially. There are a number of other different tools out there. Also, I'm going to be running another video very soon on different tools you can use for monitoring your environment. So look out for that video on this same channel very soon. So here's another really useful tool that I use on a daily basis, Remote Display Analyzer. In the free version that you can download, just type Remote Display Analyzer into Google and you'll find it pretty quickly. But the free version will give you the ability to look at what protocols your endpoint has negotiated with the system. So you'll be able to see whether you chose build to lossless, what your maximum frame rates settings were, what video codec, if any, is being used, and whether or not that encoder load is being offloaded to the GPU. But what's really, really powerful about this tool is if you pay the license for this tool, it'll allow you to change all of these parameters on the fly as you're viewing the desktop. So rather than having to log out, change the profile, the policy, and then log back in again and see what changes that make, you can actually change all of these in real time. So this is a really good way of landing on an optimal configuration very quickly. You can change frame rates, you can change the visual quality, and you can turn codecs on and off at will and actually observe those results in real time. So definitely recommend you use Remote Display Analyzer. Okay, so let's just finish up this session talking a little bit about how you would convince your management that a GPU deployment is the right way to go. Well, the first thing that I would do is talk a little bit about how it can help you with density. Because a lot of the workload within that virtual machine is being offloaded to a GPU, what that results in is your CPU utilization is lower. Okay, you can see a couple of graphs at the top there. We can actually run more users on our server because we have lower CPU utilization per virtual machine. Another thing I did with actually GPU Profiler in this case was produce the graph down the bottom. So I set up a little workload that I was going to do myself. I did some video playing within Chrome. I then rested for 30 seconds or for a minute actually, just to so I could see what was happening when during the GPU Profiler trace. I then launched a PowerPoint slideshow and actually showed how interactive that was, both with and without a GPU. I then rested again. I then went into Excel and did some spreadsheet manipulation just to show how that changed the GPU load. And finally, I went in and did some web browsing and scrolling up and down websites, that kind of thing. And with the GPU Profiler information, you can export that to CSV, pull it into Excel and very quickly produce a graph of what was happening during that time. And as you can see within here, it gives you some really good information on how high the CPU utilization was before we had a GPU and the comparative results of CPU utilization with a GPU. And this information can be really compelling. The second thing I would do is say there's a whole bunch of videos out there that will allow you to look before and after a GPU so you can assess the difference in terms of how smooth that desktop is, how interactive it is. So there's a load of videos on YouTube. I definitely recommend that you do that. But also, more than that, if you're designing a vGPU deployment that's going to last you the next 5 years, you want to think about the applications that you're going to want to deploy over those next 5 years, which, you know, quite often can be more graphically challenging or graphically demanding than you have right now. The possibility that certain projects haven't happened yet because maybe you didn't have the infrastructure needed to deploy those projects are now possible. So make sure that you take a look in the next 5 years on that and size your GPU deployment accordingly. One of the things that I find if I'm at a trade show or something and I want to show the difference between a GPU-enabled virtual machine and a non-GPU-enabled desktop is I'll use something like a WebGL application. These are really good at showing GPU load and smoothness, and it's very, very visual to see. So here are a few websites that I use when I'm at trade shows to actually show people the difference with and without a virtual GPU. And I'll put some of these links down in the description below just to give you some more information on that as well. Okay, so to summarise, we talked a little bit about some of the common mistakes that people make when sizing a virtual GPU deployment: too much density, wrong benchmarking tools, that kind of thing. We then gave you some information on where to start when you're sizing a virtual GPU deployment and some standard recipes that you can use. We talked a little bit about some of the useful tools that you can use for sizing, and don't forget there's going to be a video on my channel soon which goes into these tools in a lot more depth. And lastly, we finished off by how you can convince others that a virtual GPU deployment is the right one for you, and some of the tools that you can use and websites that you can use to show the difference between virtual GPU and non-virtual GPU to help you convince them. Here are some really useful links that you can use to further your knowledge of GPU. I'll also be posting these links further down in the description for future information. Okay, so I hope you found some useful information in there about how to size virtual GPU deployments. I look forward to talking to you again in part 3, where I'm going to be covering my top tips for getting a successful proof of concept.